What if we told you that you might be living inside a black hole right now? These strange and powerful cosmic giants are usually seen as some of the most incomprehensible phenomena in the universe. But now, a groundbreaking analysis based on observations from the James Webb Space Telescope suggests a jaw-dropping possibility. Black holes may actually be far more life-friendly than we ever imagined. In fact, the study proposes that our entire universe may have been born inside one of these gravitational titans. But what exactly did Webb uncover? Are we really trapped inside the core of a black hole? And what could this discovery mean for our understanding of reality itself? Stick with us to the end as we unravel this fascinating cosmic mystery. There are regions in the universe where the familiar laws of physics seem to break down, places where the forces at play are so intense that space and time themselves warp and twist. These are the domains of black holes, cosmic vacuums that devour anything venturing too close. So what gives a black hole its incredible power? How can something that is effectively invisible wreak such havoc on its surroundings? Or, does it even do that at all? Black holes are most infamous for one terrifying trait: anything that crosses their event horizon, the boundary beyond which escape is impossible, is lost forever. Matter, energy, information, even light, nothing returns. This is because black holes are unbelievably compact. Their enormous mass is compressed into an incredibly tiny space, creating a gravitational pull so strong that not even light can break free. To grasp just how extreme this is, consider this: a black hole with the mass of our Sun would have an event horizon only about 6 kilometers wide. That's tiny compared to the Sun's actual diameter of 1.4 million kilometers. If Earth were to become a black hole, it would shrink to the size of a marble, yet its gravity would become unstoppable. If a black hole had the same mass as our planet, it would be no larger than a marble. But that's purely theoretical. In reality, these gravitational giants possess masses that stretch the bounds of imagination. Supermassive black holes, for example, can surpass the mass of our Sun by millions, or even billions, of times. A prime example is the black hole known as 618, located in the constellation Canes Venatici. This astronomical behemoth is estimated to weigh a staggering 66 billion times the mass of the Sun, an extreme case that illustrates just how far cosmic phenomena can go. It's important to remember that black hole research is still relatively young. The term black hole was only coined in 1967 by theoretical physicist John Archibald Wheeler. From that point on, scientists began confirming the existence of these once purely theoretical objects. Over the years, astronomers have repeatedly observed the powerful effects black holes have on their surroundings. But a groundbreaking moment came in 2019, when astronomers captured the first ever photograph of a black hole. This unprecedented image allowed researchers to study the appearance of these cosmic giants more closely than ever before. This achievement naturally sparks a profound question: how can you photograph something that, by definition, is invisible? After all, as mentioned earlier, not even light can escape from a black hole's grasp. The answer lies in the material around the black hole. Rotating black holes are typically encircled by what's known as an accretion disk, a swirling ring of superheated matter falling inward. While the black hole itself emits no light, this surrounding material does, providing just enough illumination for us to capture its silhouette. Simply put, this is the pathway through which a black hole feeds. More specifically, the accretion disk is the region where incoming matter is pulled in, rapidly accelerated, and compressed under immense gravitational forces. As particles within this extreme structure collide and rub against each other, they release vast amounts of energy, creating powerful jets that shoot far beyond the host galaxy and into the intergalactic void. These brightly glowing disks, which stand out vividly against the darkness of space, enabled scientists to capture the first direct visual evidence of a black hole in 2019, thanks to the Event Horizon Telescope. To understand the power of this ground-based array of radio telescopes, consider this: if our eyes were as sharp as the Event Horizon Telescope, we'd be able to see individual molecules on our hands. While we can't do that, what we can do is examine what the data revealed about the active core of the galaxy Messier 87. Located in the Virgo constellation roughly 55 million light-years from Earth, this giant elliptical galaxy became the site of a historic breakthrough. The iconic image captured shows the glowing shadow of a supermassive black hole at its center. This visual is the result of intense light bending, gravitational lensing, right before the light disappears into the black hole. The ring you see around the central dark area is superheated matter, its light warped and magnified by the black hole's own gravity. The observation also allowed scientists to accurately estimate the black hole's mass at a staggering 6.5 billion times that of our Sun. So, if black holes are capable of such immense power, it begs the question, why aren't they simply cosmic killing machines? Hold on a second, if black holes are known for obliterating everything in their path, how can one sit at the center of a galaxy without tearing it to pieces? Shouldn't it rip its surroundings apart entirely? Surprisingly, the answer is no. In fact, it's now widely accepted that nearly every galaxy harbors a supermassive black hole at its core. Far from being destructive forces alone, these cosmic giants actually play a crucial role in shaping galaxies. It's important to remember that beyond the event horizon, the point of no return, black holes behave just like any other massive object in space. Outside this death zone, other celestial bodies can orbit them in perfectly stable paths. The Milky Way is a prime example of this. At its center lies a supermassive black hole known as Sagittarius A*, located over 26,000 light-years from our Sun and weighing approximately 4.15 million times the Sun's mass. In 2022, this immense object was finally photographed thanks to the Event Horizon Telescope. The image revealed a familiar dark center surrounded by a glowing ring, confirming, once and for all, that a black hole does reside at the heart of our galaxy. But more than just confirmation, the photo offered astronomers new insights into how black holes interact with their environments. Yet, despite these advances, one fundamental mystery remains: what lies inside a black hole? The truth is, we still don't know. According to classical physics, the core of a black hole is a singularity, a point of infinite density where spacetime curves infinitely and the known laws of physics break down. However, many researchers believe the singularity may not be a physical reality, but rather a sign that our current theories are incomplete. Instead of a singularity, there may exist an entirely new state of quantum matter, possibly an ultradense core where the classical concepts of space and time break down. Theoretical frameworks like string theory and loop quantum gravity attempt to describe such exotic states, though neither has achieved full success yet. Still, the true nature of what lies beyond a black hole's event horizon remains unobservable. As mentioned earlier, no information can escape from that region, making it one of the greatest mysteries in astronomy. But what if we've already been looking at the inside of black holes, every single day, without realizing it? Surprisingly, this isn't some far-fetched idea from the scientific fringe. It's a serious hypothesis being debated among scientists, based on recent findings from the James Webb Space Telescope, JWST. A research team led by Lura Shamir at Kansas State University analyzed over 260 early galaxies in a region known as the Jades Field, previously observed by Webb. What they found was astonishing. The majority of these ancient galaxies appear to rotate in the same direction. Roughly 2/3 rotate clockwise, while only a third spin counterclockwise. Why does this matter? In a universe governed by randomness, we'd expect an even distribution of galaxy rotations. But the data tells a different story, raising questions that demand explanation. One possibility: though less exciting, involves measurement errors.